All right, so here's the answer for the question. I showed the solutions. First of all, they state that a is equal to -1/4 because that's the coefficient in front of that f of x. So two things are going to happen. Because of the negative sign, you're going to get a reflection across the x-axis, and because a is between 0 and 1, you're going to get all the y values are going to get multiplied by 1/4. They don't actually show a nice graph. They have a table of values where they show the x and the y of the original, and now the image, the x stays the same each time, but the y value gets multiplied by -1/4. So let's go over to Desmos, and I made one here. So here's my original. F of x is equal to the absolute value of x, so this is the way Desmos does the vertical lines there. And I made a nice slider here, so if I make it larger, there you can see the vertical stretching when a is larger than 1, and when a is between 0 and 1, all right, you get the vertical compression again. And now when we go to -1, it's upside down, but we want -1/4, don't we? So there, that's how it looks, the -1/4. And so that's what your answer should look like. If I just pop back over here for a second, they also tell you the domain and the range. So looking back on my original, the orange one, all the x values, the domain is all real values, and the y, the range, is greater than or equal to 0. And now because of that reflection, the range now is going to be less than or equal to 0 because of that negative. But the x values are still unrestricted. This will be all real values. All right, well, let's carry on. And on the next page, over here, they say, consider this graph y is equal to x cubed. And now you see what they're doing. Now they're not putting a coefficient out front. They're putting it inside of the function. So you know what, let's go over and take a look at the Desmos. I think something more interactive is better than just reading the text here. So I'm going to put in a more interesting function over here. I had written one down here. Let's see if a copy and paste works. There we go. So there's a nice looking function. Let's put this back to 1 so it doesn't get all confusing. Okay, so orange, I got an orange and a red on top of it. So here's my original function. And we already know what happens when we play with the a values, right? So here I'm going to do some vertical stretching and vertical compression. And then here's the negative, so it goes reflection. And then a -1 is just the same size, but now larger than -1, or I should say farther from 0 than -1. I get the reflection because it's negative, and I get the stretching. Okay, so let's place that just back at 1 so I don't have any vertical stuff going on. If I move my toolbox maybe to the other side here. So on the bottom I mentioned here, so if A is on the outside, if that causes vertical stretches and compressions, B on the inside of the function is going to cause horizontal stretches and compressions. And you see I put this word reciprocal because it's kind of the opposite of effect of what you had before. So just one more time, if I make A larger, then I get a vertical stretch. Okay, now what happens if, and I'm going to show my B here, so here's my B. If I make this larger than 1, oh, I get a horizontal compression. Do you see what's happening? As I'm making a larger than 1, you see it compress horizontally. So here would be, imagine if you put your left hand over here and your right hand over here and you squish the graph paper together, that would be a horizontal compression. So that's why I wrote the word reciprocal there, because it's the opposite of what you would expect. It's between 0 and 1 now. So if I make the B value smaller, now I'm getting a horizontal stretch. So it's, again, it's like the graph paper is made out of rubber and you put one hand over here and one hand over there. If I was in class, I'd be having paper and trying to stretch it, pretending it's rubber, so you can see that it's getting horizontally stretched. Okay, so what happens, having trouble here. What happens when I go negative? So I'll go negative, say -1 first of all. Okay, so it's not too surprising. It's just like we learned before. If we put a negative sign inside of here, you're multiplying all your x values by -1, so it reflects across the y-axis. So here is the y-axis. It reflects across the y-axis. If I continue to go and I make a larger than -1, I have two things happening. I've got the reflection happening, plus I've got a horizontal compression. And here I've got a horizontal stretch. Okay, so could we put this all into words. This is a neat thing. It's not really part of our course, but when you play with the stuff, you see that's kind of cool. If I make b into a 0, 0 times x is 0, so then really what it's doing is it's saying what on the original function, what happens if when y is 0. So y is 0 when x is 4, so that's we've got a horizontal line at 4. Fun things to play with. But let's go over here and see where they state the rules. So here's where they do that. And I think we can put it in a similar way. This is how they explain that kind of reciprocal manner. It's not quite the way I like to explain it, but I think we can make sense of this. If our original If our original function is y is equal to f of x, and we are making an image, and in this case, just like before, but instead of putting an a outside, we're going to put a b on the inside. Okay, so it's not too hard to imagine. If this is inside of the function, then this is going to be changing the x. So, and on the axis, x is, causes things to compress or stretch. It's going to cause a horizontal change, right? Because we're going to get those types of either a stretch or a compression. So you're going to get the x values change. So if our original one was x comma y, if any point on the original graph, okay, so here's an original point. So there's a spot, x comma y, right? And we're wondering what's going to happen. So maybe my x is -2 and my y is 4 or something like that. On my new graph, the image of the old one, the x values are going to get divided by b. Okay, so recall before when we did that a out here, the y values got multiplied by a. Here x is getting multiplied by the reciprocal of b. Okay, they're getting multiplied by 1 over b. Oh, I kind of I should erase this part here because I need an ordered pair, so I'm now going to put comma. Since there's no number out front, I'm just doing an a value of 1, then my y's stay the same. Okay, so this point here on the original graph corresponds to or becomes this x over b comma y on my image graph. A couple things is that if b is negative, is less than 0, so what's happening is my x values are going to get multiplied by -1, and I'm going to get a reflection across the y-axis. Just like we saw before, we're going to get this reflection across the y-axis. I think they call it a reflection in the y-axis. Sometimes you'll see they'll say horizontal reflection, but you know what? Let's just use the same phrase. Now we'll say if the absolute value of b is less than 1, so that was when I was playing around there, and it was like 0.2 or 0.3 or -0.2 or -0.3. Before with the a values, and we were changing the y's, a smaller one made a compression. It kind of made sense. This one's the opposite of that. So if it's a smaller one, then you're going to get a stretch. You're going to get a horizontal stretch. It gets larger. And if the absolute value of b is greater than 1, then we're going to get absolute value b is greater than 1. Hopefully you can read my writing okay. Then we're going to get a horizontal compression. I hope that makes sense. Let's take a look at our next example over here. We'll try. Okay, so in this example, you have an f of x, and now our b value is going to be equal to -3. Here they state it, b is equal to -3. So just a reminder that all the y values are going to stay the same now, but our x values are going to get multiplied by the reciprocal of -3. So the reciprocal of -3 is 1/3, so you're going to multiply them by -1/3. So -6 multiplied by -1/3 is +2. -3 multiplied by 1/3 is +1. Okay, and so on. So It's a little bit hard to see it. Here's the original. Okay, so there's two things that are happening. First of all, it's reflecting, so like this piece goes over there and this piece goes over there, so that this kind of incline switches sides. And then there's also the compression, because this absolute value of b is greater than 1, so you get a compression on there. If you do the table of values and do it properly, this compression will happen automatically. You don't have to worry about it too much. Now when you talk about the domain and the range, the domain is all the different possible x values, so it's going to be between -1 and +1. So this is a scale of 2, so between -2 and +2, so this is the best way to state it. And the range is, it looks like the smallest y value is -4 and the greatest y value is 246. So that's where this range comes from. Okay, it seems kind of straightforward, but you know what? I'm going to let you try this, check your understanding, and I'll come back and see you just in a minute.